Hey everybody, welcome to the first lesson in our new unit called set theory. Now this will be very new, this unit, to all of us. It'll probably be very unfamiliar, something like you've never done before in math, but I honestly like this unit quite a bit. The reason why is that for some of us, the algebra piece that maybe gets in the way of the other units and that we struggle with a bit, I'm thinking rationals here, we don't have in this new unit. Okay, so some of you will really like this unit. What I need you to know though is that there are some definitions and some things that I really need you to know. So we'll work on those as we go through here today. Okay, set theory is all about organizing things. And really, I mean, that's the goal of math in general, is how do we organize things? You've done a lot of this maybe in different classes. I'm actually thinking social class, where you've drawn some diagrams that look like this to maybe describe people's personal points of views on things. Maybe you're discussing, left-wing politics versus right-wing politics, right? So you've done some of this before. It's just about putting it into a little bit more math detail. Okay, let's get going. So the first thing we're going to talk about is set notation. So a set is a collection of objects. Okay, and we use this notation, and we use this in domain and range. If you remember that those two braces mean the set of. Now, just like in chemistry class or biology class, the things that make up the bigger thing are called the elements, right? So each individual item in a set is called an element. So they're the small things that make up the big thing, the set. Now, so here's our first example. We're going to consider the English alphabet. So if I wanted to list out the set of vowels, I'm maybe going to call it just V, and I'm going to put my brace there, which means the set of numbers, and I'm going to start listing them out. A, E, I, O, U. Now someone just screamed out, what about Y? No, in math, Y will never be a vowel. Okay? If I'm not a vowel, I'm a consonant, so I would write out everything else. And I'm going to skip a bunch here because I don't want to list them all out. It's a bit of a pain. So when I'm skipping something or a list is continuing, you're going to put 3 dots. There it is. And all letters, do you see how all letters is a capital U? That U is an important letter. It's an important way for us to classify this set. Do you notice that the set U has all of the vowels and all of the consonants in it? This set U is called the universal set because it includes all possible elements. Okay, so we're going to keep thinking about our universe, which is a bit strange because it's not, looking up at the stars and the heavens. Our universe will change on every question. Now, in the question above, okay, U is called the universe because it includes all elements. Okay, what can be said about the elements in set C in relation to those in set U? I'm going to say that all of C, and the keyword there is all of C is inside or contained in U. What can be said about the elements of V, the vowels, in relation to set U? I'm going to say the same thing. All of V is contained or inside of the universe. So these have a special name. When all of the elements are contained in another set, I'm going to say this is called a subset. So subset means all of the elements. All of the elements. I'm going to keep underlining all. All of the elements are in the other set. And we give it this symbol. It's almost like an elongated C. So In our example, we can write that C is an element of U. V is a subset of U. Okay, just like that. Okay, so what we're really doing is just taking our words and turning them into the international language of math. Okay, so a couple definitions there: universal set, element, subset. Okay, now I'm going to look at C and V. It says, what can you say about the sets C and V? Do they have anything in common? Nothing in common, right? There's nothing in common. So when none of the elements in one set are included in another set, we say that these sets, when they have nothing to do with each other, we call them disjoint. So if we wrote out the number of elements in this set, they have nothing to do with each other, right? They don't overlap. I would call this the empty set, right? Because here's my vowels and here's my consonants. They have nothing to do with each other. They are called disjoint. Okay, now the next question says, write out all the elements that are not in C. Well, if I'm not in C, what am I? I'm in V, right? Not C. If I'm not a consonant, I'm a vowel, yeah? The elements of this set are called the complement of set C. Now, not the complement like, geez, you smell pretty. The complement like what I don't want. What I don't want is what is in C. I don't want a consonant, I want a vowel. Now, the notation here you got to pay special attention to is a C with just this little prime right there. Okay, this prime right here, that means not. Okay. Next question. What would happen if we added the elements in C and we set all the elements in not C together? Well, what that says is that's consonants plus not consonants. Well, really that's vowels. So guess what we get? We get all letters, also known as the universal set. Okay, so that's important. Now, how many elements are there in set V? Well, they're vowels, and we didn't include Y because it becomes a bit of a problem. I'm going to say there's 5. Okay, so when I ask you to write the number of elements in a set, if you're using the textbook, and this is proper notation, but for some reason we were asked not to use it in 30-2, it would look like this. Okay, it would say N for number of, bracket V, the number of elements in V. So I would answer that as 5. Okay, that's proper notation. But again, for some reason on the diploma, we're not going to see that. In Math 30-2, we won't see that. I don't know why, even though it's proper. Okay. So whenever we add a set and its complement together, we will get the universal set. Okay, that was the key thing from there that I really wanted to focus in on. This is important. Okay. Now, like I was saying earlier, what you've seen these before. In social class usually is where most people tell me they've seen it. An easy way to draw these things is a Venn diagram. Okay, so a Venn diagram is us drawing sets. And I'm going to say this is the set C. And I'm going to say this is the set V. They're disjoint, so they're not touching each other. Okay, and on the outside, we're always going to put this box all the way around it. This is called the universe. So I'm going to label whatever my universe is there. In this case, I'm just going to say U for all letters. But in other cases, we're going to have something different. Okay? And it never hurts when you're doing these questions to maybe label how many elements are in each. Okay, I know there's 26 letters, so there's 5 vowels and 21 consonants. Okay, so this is called a Venn diagram. I highly suggest you draw these out. Draw, even if the question doesn't say to, draw it. Okay, let's try a question. Now we've got to be, again, there's going to be a lot of definitions in this unit, okay? But once you get those definitions down, I would write these down on a separate piece of paper, maybe the back of my formula sheet. Okay, we're going to consider the set of whole numbers. Remember, whole starts at 0. We're going to consider the set E of even numbers, and let O be the set of odd numbers, and let N be the set of natural numbers. Okay, so we're only considering the numbers from 0 to 10. Okay, even numbers. First thing I need you to know, 0 is an even number. The definition of an even number is divisible by 10, or by 2. So an even number is divisible by 2. So 0 divided by 2 is 0. 0 is even. Odd numbers, not divisible by 2. Natural numbers, I really need you to know, natural numbers are the numbers you first start learning when you're really little. Okay? You start counting on your fingers usually. Well, you don't, the idea of 0 isn't actually a natural thing. It takes a little bit of higher thinking to come to the idea of 0. So natural, I start at 1. Okay? Whole numbers back here, whole numbers I always say are the number that start with the whole in the middle, 0. Okay, I listed out my sets. List the complement of set E. So I want not E. That's E prime. The complement of set E. Well, if I'm not even, I am odd. Just like that. Okay. Then the next question says, list any disjoint sets. So disjoint means they have nothing in common. No common elements. Okay, well, the evens and the odds. They've got nothing to do with each other, right? Nothing to do with each other. There's nothing in common, okay? The odds and the naturals, they have common numbers. The evens and the naturals, they have common numbers. Okay, so there's your disjoint set. Okay, now, true or false? And if it's false, state why. If it's false, tell me why it's false. So, are the even numbers a subset of the naturals? Are all evens in the naturals? The answer is no. What's an even number that's not natural? 0. Okay, keep an eye out for 0. It pops up a lot in this unit. Okay, so I need you to remember 0 is even. Okay, are even numbers from 0 to 10 a subset of the whole numbers? Yes. All the evens are also whole numbers. Okay, this one here again, E prime says not even. Well, if I'm not even, I'm odd. So this is the same thing as saying, are the odd numbers a subset of the whole numbers? Absolutely. All odd numbers are whole numbers. Next one asks us, are whole numbers a subset of the naturals? Are all whole numbers inside the natural numbers? No. 0 again. 0 is a whole number that is not natural. And last one here, let's go for pretty orange. Again, I see this not. This is not odd. Well, if I'm not odd, I am even. I could say this. Are the even numbers a subset of the even numbers? Yeah, I'm a subset of myself. Absolutely. Okay. Now, again, there is a proper symbol for that. This is called a proper subset. We won't use this symbol, but it is actually correct. Okay? I just need you to know if you come across it anywhere that that is a correct symbol. Okay. This is really important. Consider the sets of prime numbers and composite numbers. Okay, I need you to know our first prime number is 2. Remember, a prime number means I'm divisible by 1 and itself. The composite numbers means I can be made up of more than one thing. Okay, so I have more than the factors of 1 and myself. Okay, notice that 1 is neither prime or composite. Okay, so what do these two sets have to do with each other? How would I describe them? In set theory, I would describe them as disjoint. They have nothing to do with each other. Okay, if I was to draw a picture, it would look like this. There's my primes, there's my composites. They have nothing to do with each other. Okay. Now, a lot of times you're going to get a question and the Venn diagram will be drawn for you. So I've got this funky looking thing here. It says Johan has the following sets. So he's talking about maybe his favorite foods or something. Okay. So it's a pretty picture. Love it. Okay. It says, what are the number of elements in V? So in V, I just go and I count. I got peas, corn, carrots, potatoes, beans. I'm just going to say 5. That's my answer. List any disjoint sets. So that means they have nothing to do with each other. Well, F and V, fruits and vegetables, have nothing to do with each other. Don't forget about S and V. Okay. Just because S is inside of V, it is its own set. Now, if I really wanted to, mushrooms are flying around there as their own, but it's not listed up in here in a set. So I'm just going to leave mushrooms by itself. Okay, is F prime not F equal to V? Well, if I'm not F is everything outside. Not F is everything on the outside of F. I'm going to shade that like that. It's everything on the outside. Well, is everything shaded equal to just vegetables? The answer is no. What are we missing? We're missing those mushrooms. Okay, so I find it really helpful if I've got a Venn diagram to draw on it. Okay, last question. List the elements that are not in S. Well, everything that's not in S. Change my pen, maybe I'll go to black. Not S. So I'm going to go and I'm going to circle S, and I want everything that's not in S. So I'm going to shade. All of this is not S. So the shaded is not S. So I would list this out. I would say oranges, bananas, pineapples, peas, corn, carrots, potatoes, beans, mushrooms. Okay. Or what might be a better question is to say how many elements are in not S. I just count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9 elements. Okay, so one of the things I want you to think about when you're getting these questions is drawing a Venn diagram if it's not given to you, and think about shading. As we go further on through this unit, if you can visualize what we're doing, it's really going to help. Okay, let's wrap this up. The braces are used to define a set. This sideways looking elongated C means subset, meaning all the elements of one set are contained in another. A Venn diagram is an easy way to graphically show sets. Two sets are called disjoint if they have nothing in common. complement A prime is the set of elements not in the set of A. All elements of all sets together give us the universal set. And again, the textbook, and this is proper notation, will use this here, which means to find the number of elements in set A. So it's not wrong to use it. We just won't see it on our diploma, which is not the end of the world. Okay, my friends, there's your first lesson in set theory. Really, it's about those vocabulary, and think about prime and composite. Those are going to be two big ones. Hint, hint, nudge, nudge. Okay, until next time, hope you're all doing well. See you soon.